Hey guys, this is part 2 of your video for this Friday. We're going to continue looking at functions and identifying, interpreting functions, especially rate of change. So, looking at number 1, it says the function Rx represents the radius of a circle for a given area x. A graph of the function is shown in the figure. According to the graph, what is the approximate average rate of change in the radius of the circle as the area increases from 3 square feet to 7 square feet? So the average rate of change. Go ahead and try to calculate that, and then we will just be right back with the answer. All right, so to calculate average rate of change, we need to look at where this is 3 feet and where this is 7 feet. Average rate of change is that slope that we're looking for. It's that slope. So what I can do is when I'm looking at this graph, I can say, well, my rise is from 1 to 1.5. So my rise is 0.5 or 0.5. And my run is from 3 to 7, which is 1, 2, 3, 4. So if I take 0.5 and divide it by 4, I get 0.125. So my answer is A, 0.125 foot per square foot. All right, looking at number 2, we've got this table here. A scientist measures the water temperatures in the Gulf at Gulfport on the 15th of each month. Her data is shown in the table. What is the average rate of change between March and June? So what we need to figure out is, well, what is that average rate of change? So remember, rise over run, change in y over the change in x. So go ahead and calculate that rate of change, and then we will discuss the answer. All right, so we have our x, we have our y. So our change in y, 82.4 minus 66.8 over June to July. So this would be a 1, 2, 3, 4 month change. March to June would be 4 months, the third month going all the way up to that 6 month there. So a 1, 2, 3, 4 change. So if we calculate this, 4 months, I meant 3 months right here, March to April, April to May, May to June, 3 month change. Then 82.4 minus 66.8 is 15.6 over 3. So my average rate of change would be 5.2 degrees Fahrenheit per month. All right, looking at this last one, it's quadratic. So during the first years of growth of a height of a tree can be modeled by the equation where t is time in years since it's been planted and h is the height. We want to know from year 1 to year 5. In order to calculate that, we need to calculate, well, what is F5? What is that change? So go ahead and try to calculate that, and then we will show the work. All right, so if I plug in 5, so we've got 5 squared plus 12 times 5 plus 10 minus, this is the most important thing, that you use parentheses when you plug this in. If you did not use parentheses, you may in fact have gotten it incorrect. 5 minus 1 is 4. So 5 squared, this would be a negative 25 plus 60 plus 10 minus 1 squared is 1 times that negative on the outside plus 12 plus 10 all over 4. So we can start combining here. Negative 25 plus 70 minus 11 plus 10 is 21 all over 4. Lots of math here. So we've got a negative 25 plus 70. I'm going to go ahead and just use my calculator here. Minus 21. So we've got 24 over 4. So our average rate of change is 6. So each year this tree is growing about 6 inches. All right, checking out this last standard here. Last standard for these videos. So we're going to interpret rate of change. The distance in miles y a bicyclist traveled from his home after riding x hours is represented by the equation y equals 8x plus 7. What does the slope represent? So that slope right here is 8. So that represents what? Go ahead and pull in. That represents the speed of the cyclist. It represents the speed of the cyclist. Very nice job. All right, let's go ahead and look at a table of information here. So we've got this table and it shows the playing times in minutes of high definition videos and the film sizes of these videos in megabytes. What does the slope of this graph represent? So go ahead and try to interpret this graph, read through A, B, C, and D, and then we'll discuss the answer. You guys are right. The increase in the file size of the video per minute of playing game. So this file size is increasing as my time is increasing. That's what it's telling me. Last graph. So which is the graph of a linear function with a slope of 2 and an intercept at 0, 1? So I've got two graphs, A and D, that both have an intercept of 0, 1. But which one has the slope of 2? Well, that slope of 2 would be A. I'd be rising 2, running 1. If you said D, you've got your rise and your run maybe a little bit off. This would be a rise of 2, a run of 4. So this, or run of 3, I should say. So this would be 2/3. So there you have it. A is your answer. All right, nice job, guys. Please remember, you should be practicing these standards every single day in USA Test Prep as we prepare for that EOC. Can't wait to see you all in class. Have an awesome day. Goodbye.